parallelograms, what were they? Opposite sides are congruent. Diagonals bisect each other. Consecutive angles supplementary. Opposite angles are congruent. Sides are parallel. Good. Opposite sides are parallel. That last one was just the definition of parallelograms. The opposite sides are parallel. Okay, well today, so we said, here's this parallelogram, now you know all this stuff about it, okay? That was yesterday. Today, we're going to say, here's something I know about this shape. Is it a parallelogram? So instead of saying it's a parallelogram, now you know this is true, I'm telling you, okay, this is true. Can you tell if it's a parallelogram? So, so instead of saying parallelograms have four opposite sides are congruent, we say if a quadrilateral has opposite sides congruent, then it's a parallelogram. If a quadrilateral has opposite angles congruent, then it's a parallelogram. If a quadrilateral has consecutive supplementary angles, then it's a parallelogram. If diagonals bisect each other, then it's a parallelogram. Do you see where the difference between what we did yesterday and what we're doing today? Right? Okay. And then the last one, based on the definition, if the opposite sides are parallel, then it's a parallelogram. Okay? And then, so I would jot these down or somehow rearrange your notes from yesterday to show that these are also true, that the converses are also true. And then the last one is kind of new. We talked about yesterday, but it's not really a characteristic that we learned yesterday. That is, if one pair of opposite sides are parallel and congruent, both, one set of sides are both, then it's a parallelogram. So like the picture of that would look like one set of sides is congruent and parallel. Okay? So for sure, make sure you get that one down and then somehow either copy just these statements. I don't think you need to copy all the words down, but at least the statements. Okay? Is it a parallelogram? It's the game where we decide if a picture is a parallelogram. I'm your host, Stephanie Archer. My guests today are 9/10 period, and we are going to decide if it's a parallelogram. Yay! Right? We are going to all play. If it's a parallelogram, you're going to raise your right hand. If it is a parallelogram, raise your right hand. Raise your right hand. That's your left hand. Raise your right hand. That's your left hand. There you go. If it's not a parallelogram, you're going to raise your left hand. Raise your left hand. Awesome. Everybody got it. All right. All right. So, number one. Is it a parallelogram? Raise your right hand or your left hand. Right for yes, left for no. Okay, we look pretty consistent. Ian, you think it is a parallelogram? Why? Or these are consecutive angles. Consecutive angles should be supplementary. A linear pair has to touch, but they should be supplementary like a linear pair. Right. So are they supplementary? Yes. So is it a parallelogram? Yes. Ding, ding, ding. Points. A million billion points. Good job. All right. Next one. Is it a parallelogram? Right for yes, left for no. I still have a couple more people that need to decide. have to pick on someone. Maria, why? Sides. Okay, the top. Okay, do we have two sets of opposites? Two sets of congruent sides? No. These are what? Parallel. These are congruent. So do we have two sets of congruent sides? Do we have two sets of parallel sides? Do we have one set of sides that are parallel and congruent? No. This is a tricky one. I think it fooled everyone in here. The answer is no. It is not. You did? Oh, I didn't see you raise your left hand. You did? No, I didn't see you. I would have called on you if you right there. All right, because one set of sides has to be congruent and parallel. So it would have looked like that if it was one set of sides, or it would have looked like that. The one set of sides parallel and congruent. Does that make sense? Okay. All right. This one, right for yes, left for no. Is it a parallelogram? CJ, why is it a parallelogram? We don't know about the sides. What do we know about? What are those purple things? Starts with a D. Somebody help them out? What are those purple things? Diagonals. What do we know about the diagonals of a parallelogram? They bisect each other. They're both equal on each side. Are these equal on both sides? Do they bisect each other? Yes. So it is a parallelogram. Now let me quick give you a hint on tests. I like to do this because I want to make sure you know what you're doing. Is that a parallelogram? Why not? Right, I can't fool you guys. Right. These two would have to be equal, and these two would have to be equal. Right now, they're not. They don't bisect each other necessarily, right? Okay, good. So this one is not a parallelogram. All right, how about this one? Is it a parallelogram? Right? For yes, left for no. Hallie, why would it be a parallelogram? Awesome. One set of parallel and congruent sides. Is this a parallelogram? Oh, sorry. Ding, ding, ding. Million, billion points. Is this a parallelogram? Okay. Laura, why? Right. Opposite angles are congruent, so it is a parallelogram. Good. So that's a y. Awesome. Okay, feel like you can, that's our target today, determine if something's a parallelogram based on its characteristics. Can you do that? Good. Okay. All right. Second to last thing we're going to do is we are going to prove that something's a quadrilateral on a coordinate proof. Or, sorry, that something's a parallelogram on a coordinate proof. Okay, so that means we're going to have calculations, a statement about those calculations, some more calculations, another statement, and then a summary. So ordinarily, if I just said, is this quadrilateral a parallelogram, you could choose any of the characteristics you wanted. You could say opposite sides are congruent. You could say opposite sides are parallel. You could say one set of sides is congruent and parallel. You could pick. But in this case, they said, prove that it's a parallelogram based on that one pair of opposite sides are parallel congruent. So in this case, we can't choose. But if it had just said, is this a parallelogram, then you could have chosen whatever method you wanted. Does that make sense? I don't want you to think this is the only way to do it. There's lots of different ways, but in this case, they told us we had to do it this way. So the first thing I'm going to do is graph it. So I graph, and I would sketch this in your notebook so you have it. Here's A, B, C, and D. So here's my parallelogram, or my quadrilateral. I don't know if it's parallelogram yet. And I have to prove that opposite sides are parallel and congruent. So first I have to pick a pair of opposite sides. So pick for me. Then pick the two sides we're going to use. AB and DC. Okay. So we're going to use AB and DC. And we have to prove that those two are parallel first. What calculation do I do to prove things are parallel? Slope. Good. And what about the slope? What will they be? If they're parallel, what will happen to the slopes? They'll be the same. Good. So I calculate the slope of AB. Now, it is a graph, so you are welcome to count. I'm going to calculate it because I figure you can all count on your own. So I'll calculate it just to remind everyone how to do it. So it's y2 minus y1, so 3 minus 2 over x2 minus x1, 2 minus 4. So that's 1 over, oh, sorry, 6. I did the math in my head already. So that's 2 over negative 4. So the slope of AB is negative 1/4. Okay? The slope of DC is 1 minus 0 over 1 minus 5, which is 1 over negative 4. So the slope of this one is negative 4. So what's my statement going to be? Why did I do that? Why did I calculate that? They're going to say that they're parallel. My statement, remember calculation statement, so my statement is going to be that AB is parallel to DC. This is the reason, the calculation, that slopes are the same. Okay? Yes? No. If it's false, it can't be a parallelogram because opposite sides would have to be parallel. Okay? All right, now it says so I prove they're parallel. Now I have to prove they're congruent. How do I do that? What calculation? Distance, okay? Or the distance between 2 points is the length of the side. So I'm going to find the length of AB and CD. Okay, length or distance is, the big giant square root. So I do big giant square root for AB, which is 2 minus 6 squared plus 3 minus 2 squared. 2 minus 6 is negative 4. Negative 4 squared is 16. 3 minus 2 is 1. 1 squared is 1. So the length of AB is the square root of 17. We okay so far? Take a second and calculate the length of CD. Right, so now I need a statement. If they're congruent, then what? Here's my calculations. Now I need a statement. Why did I do that? What the heck? Why did I do that? Right. AB is congruent to CD. Okay? Right. Therefore, ABCD is a parallelogram. Okay?